In this video, I'm going to take a look at example number 3 from this section. So it means we're skipping example number 2, and I'm going to leave example number 2 and example number 4 as ones for you to try to look at on your own. Okay? But what we have here in this example, let's read what we got and see if we can work through this test. The marketing consultant for a travel agency wants to determine whether the travel concerns are related to travel purposes. The table below shows a result of a random sample of 300 travelers, classified by their primary travel concern and purpose. So we can see here that if you're going to travel, maybe you're going for a business trip, or maybe it's just for fun or for vacation or whatever happens to be, but you might have certain concerns. Maybe you're interested in the quality of your hotel, the legroom on the plane, how good is your rental car going to be once you get to where you're going, right, or some other things. And that, a company might be interested in understanding this relationship because maybe they know that hey, if business people really care about legroom, then maybe we can market to people that are potentially purchasing flights for business reasons, and maybe offer them some incentive to purchase something, a seat on the plane with more legroom, right? So there might be reasons why people might care about this. But if the general question is, at a 1% level of significance, can the consultant conclude, based on what they're seeing here, that the travel concerns do indeed depend on the purpose of travel? So when we go down to our hypotheses, we're going to see that just like last time, our H0 is going to say that the variables of travel purpose and travel concern are independent. Remember that H0 is always going to state independent, indicating that these are not related. So H1 is going to state pretty much the exact same thing. So I'm just going to kind of put these quotes here indicating that I'm writing everything the same, except that we're going to end with that these things are dependent, that they are related. Okay, so let's see. If I have these as my hypotheses, then I can start to go down to my test statistic. I know that I need to enter data into a matrix. Now to do that, I'm going to go to the calculator, and I'll get ready to do my checks once I come back. Alright, so let's go to the calculator and enter in all of these values that I see here. Notice I'm going to have 2 rows, and I'm going to have 1, 2, 3, 4 columns. Okay, so I'm going to go to second and my matrix menu. These are the matrices that we had from the previous problem. Now I don't even really need to worry about them. I'm just going to go right back to matrix A and I'm going to edit. And I don't need to worry about the numbers. I can just resize this, however I want, and then I can change what numbers are in it. So in our case, I think we want to leave this as a 2, 4, because this has the same basic setup. But we want to start to put in our numbers from our problem. Remember that we're not going to include any of the total numbers, just the numbers that are in kind of those overlapping cells. So these are the values that I have. Remember, then I can go to and run the test, because I want the calculator to update the next matrix. Oops, clicked on the wrong test there. So I want the calculator to update matrix B, and it will do that as soon as I run the test. Okay, so if you want, you could jot down these values now, but I'm going to come back to them in just a moment anyways. I'm going to go and take a look at that matrix B right away, so I can see that these are the values I would have expected if these variables were independent. And then I can start to judge, how close or how far off are the values that we actually got. So let's start running through our checks here. Remember that our first check is that we want to have counts in each cell, not percentages. And we definitely have counts for a number of people that met each description, so that's good. 2, we want to make sure that we have a random sample. The problem gives us that. Okay. This is the result of a random sample of 300 travelers. For 3, notice this asks us to start to take a look at the expected counts. So that means I have to go look at my matrix B. I want to know, are all of my expected counts greater than or equal to 1? Definitely. And I want to make sure that no more than 20% of them are less than 5. It seems like both of those, checks 3 and 4, are going to be perfectly valid. Now it's in this video where I'm going to make sure that I note for you that it's really important that as you're working through these checks, you aren't actually just checking these things off. It can be really tempting to just work through all of these different checks here and just start to kind of, without doing any calculations at all or actually looking at anything, just put a check mark down because you'll think, well, Kyle's obviously just going to believe that I checked them. Well, if you don't understand what these checks are, how to do them, be aware that on exam 4, or on the next exam, and definitely on the final exam, I will definitely be asking questions that will be testing to see if you actually know what something like checks 3 and 4 are asking. I might just ask you, hey, can you actually just fill out what matrix B looks like? But I might not say, look at matrix B. I might say, hey, can you tell me what the expected counts were? And you should be able to do that because, of course, you had to do that in checks number 3 and number 4. Okay. So I've gone through here and I've checked all the checks, and so now I can just get ready to write down my chi-squared value. Okay. I'll also come down here and get ready to sketch out my chi-squared distribution. Again, I know it's nice and skewed to the right. So let's see what we come up with. I'm going to go back to my calculator and rerun that test, just so I can see the values. Don't have to change anything in here, just go right to calculate. So let's see, I got 8.1582. So 8.1582. I'll even mark that down here on my picture. 8.1582. That's in relationship to 0. I'll then go ahead and sketch in my p-value. So my p-value is that shaded space, and I'll get it by doing the probability of a chi-squared being greater than an 8.1582. Now let's see, the calculator tells me that that percentage is 0.0429. Okay, so this is roughly 0.0429. Great. My alpha value on this question was given to me as 1%. So my p-value is larger, which means that I did not experience a rare sample. So I am going to reach the conclusion that I should not reject H0. And I'd write my conclusion as follows. So I'll say it is not rare to get a chi-squared value of 8.1582 by chance if the variables are independent. So we have no reason to doubt. We have no reason to doubt that the variables of travel purpose and concern are independent. Again, remember that means that they are not related. So there we go. Not enough evidence this time to reach the conclusion that these variables would be dependent on one another. It doesn't seem like if I know someone's going to be traveling for business purposes that I really understand or could successfully predict other things that they might be concerned with about their trip, or vice versa. So this hopefully gives you another good example of how exactly we can work through questions like this, and all of the important information about this test is summarized in the formula sheet. So hopefully you have that formula sheet, you've taken some time to look over it and look through it, and are able to use that to help you work through questions like these. Okay, I'll see you in the next section in the next video.